Probably the only time I get excited about this symbol. Very excited.
Look at that. We got 4 of those.
Yeah, and we'll tell you why in a moment. So the electrical episode is finally here, and by the end of the episode we are going to have a fully functional electrical system. So these 4 batteries are in parallel, giving us 400 amp hours at 12 volts. They go to the bus bars. That's a T-class 400 amp fuse. That is such a cool battery monitor.
Now here we have straight from the 80s, and here we have straight from the future.
Yep. The world of batteries is constantly evolving, so we left the electrical installation to very last. So let's discuss what components we chose and why, and then we dive into the installation. We will be dividing this into 6 chapters. First we talk about the batteries, then about charging those, distribution, AC, monitoring, and safety. Each of those categories requires different components and they all tie together, which in the end creates our electrical system. We should have a little tradition where every new item we bring on the bowsprit and we go Lion King with it.
And 2 more very quick but important things to say before we get into the meat of this episode. First of all, I am not an electrician or even a boat builder, but I am the filmmaker. This episode has posed a specific challenge for me because I needed to gain an adequate enough understanding of this entire system and what it does in order to present it. I have done my absolute best. That said, if there are glaring omissions or things which are not explained properly, that's likely on me, as I really had to try to synthesize this all down. The second important thing to mention is that this whole electrical build has been a collaboration with Dragonfly Energy, and this collaboration actually started about 4 years ago when we first began this refit. We have slowly, with them, designed this entire build. They did actually decide to donate the equipment for the electrical build to us. This is obviously huge. We are extremely grateful to be in this position at all. It is obviously unique and we certainly don't take it for granted. We also know that anytime anything is sponsored on the channel, that can sometimes come with some skepticism from the people watching. And I want to do my most to assure you, we put in huge amounts of behind the scenes efforts. So while the donation of the products has really helped our project, we are also fully able to share our truthful opinion of it. And I should also say, although it seems like common sense, that if you really are planning on doing an entire electrical build from scratch, you shouldn't just follow the advice of one person on YouTube. You know, we certainly never have. You use those videos, this video for example, to get some ideas for what's possible and how other people have done things. But then you change things according to your preferences, your use case, your budget, your boat. For us, this is like the best case scenario install. We're so excited about it. It's exactly what we dreamed of and exactly what we wanted to have on board Magic Carpet 1, but we just never could actually make that a reality back then. So we're kind of over the moon about this, but we're all unique. Okay, that's enough. I think you get the point.
I also do want to point out that I am not an electrician. I am a boat builder. We focus on a little bit of everything. My diagram, my schematics, they are more of a visual clarification for myself. I do my due diligence, I read, I consult people. I drew this diagram to visualize how all the components go together and help me during the install. And I'll go through each individual component and what it does. So let's begin with the batteries. We chose 100 amp hour, 12 volt, smart heated lithium deep cycle battery packs from Dragonfly Energy. So to start with the very basics, yes, we have chosen to go with lithium and we have them connected in parallel. So that gives us 400 amp hours at 12 volts. Now these batteries, as you heard from the title, they are heated. Let's say one flaw of lithium is that you shouldn't charge it when they drop below a certain temperature. That can actually damage them. So these batteries have a built-in heating pad. They consume a bit of their own power to heat up when they sense that a charge would be coming in. And that temperature threshold is not something we actually would encounter every day, but we decided let's keep all the options open. And then the smart part basically means they allow for quite a bit of communication. There is an extra device called the hub, and the hub connects to each individual battery in the system, and then through a wireless mesh can send out any information you are curious about. So I can just pull up my phone, I can see the voltage of each individual battery, and I can just see the health of the system. If there was any scenario where the BMS would do something like cut off charge or cut off loads or overcurrent protection, then you could see that on your phone and you're not just left guessing, which is really nice. This also ties into the ABYC regulations because there is system alerts, and that is one thing that is going to be required in the future to be notified of things happening. And lastly, these batteries have an internal BMS opposed to an external BMS. Now, a BMS is a battery management system. Any battery of lithium chemistry requires one. Now, basically, this is a little computer that monitors and it decides what is good for the battery and what isn't. That computer has control over a circuit breaker. If it likes what is going on, it keeps the circuit breaker open, of course, but if there is any situation that the battery shouldn't be exposed to, then it closes off. And there is many different scenarios. It can be temperature related, either too hot or too cold, where it shouldn't be charging lithium, so it shuts off. It can be current related, too much draw. It can be that the battery has fallen below a certain voltage. So there's many different scenarios and it manages those. I like that it's all within the battery pack. To me, it simplifies things. Now, that doesn't go for all internal BMSs. You also have to look into the specs because they're all made of different components. Those components can be more beefy or less, allowing more current through or less, and that is really what makes the biggest difference. Now, what I like about these BMSs is that they allow for pretty big charging and discharging. Those are, to me, two very important factors. This brings us to the next chapter, which is charging. We have three main ways for charging these batteries. First, alternator charging. Whenever the engine is running, we have a dedicated alternator only for that house bank. When we ordered our engine, we decided to upgrade to run 2 alternators so that we could keep lithium and AGM separate. Our start battery is AGM, lead acid technology, and has its own alternator. And then the high output alternator, which is a Balmar XT170 in our case, is only dedicated to the lithium bank. Along with the high output alternator, we also have a Wakespeed 500 Pro regulator. That is the brains of the operation. A regulator, as the term says, regulates. It manages the charging. It tells the alternator to increase charge or reduce charge based on the conditions. One huge advancement of the Wakespeed regulator is that it also measures current. No other regulator previously did that. They mostly only measured voltage and temperature, but there was also a lot of guesswork involved. You are also powering loads while the alternator is running, so not all of that is going into the battery bank, so you might actually still end up with an undercharge situation. The Wakespeed instead, since it also measures current, it's way more precise. It knows exactly what is drawn out of the battery and what is being replaced back into the battery. So that is one really big advancement. Another huge advantage is communication. Now it has built-in CAN bus, which, CAN bus is a communication protocol, so it can literally tap into the batteries, talk to the batteries via the hub. Some of these things are still coming via software updates that are still being worked on. But there is other brands of batteries out there as well that are focusing heavily on starting to incorporate communication, and mostly that is done via CAN bus. So the wake speed regulator can do that if the batteries can, which is pretty amazing. Second, we have light leaf solar panels. They are 110 watts each. We have 2 of those. A solar panel harvests, but then that output is regulated by a solar regulator. There's different kinds. Nowadays, MPPT controllers are the preferred ones. So we chose one of those from Victron, and we actually decided to oversize it so that we can add solar panels in the future and already have the hardware, so to speak, in place. Third, we can charge with AC. Whenever we are connected to shore power, we have an inverter charger by Victron, and that one has quite a high charge capacity as well. An inverter transforms DC power into AC power, so you can use your regular household appliances on a DC run system. A charger usually does the opposite. It accepts AC and it turns that into DC to put into the batteries. So as you can see, there's a bit of a parallel. Inverter and charger, they do a similar thing, just in an opposite direction. So the industry has just started to put them all in one package and so have a more compact, simplified appliance all in one. The next chapter is distribution. Distribution is a very important part of it. Boats are rather small and cramped. You do want to make things neat, labeled, organized, and that is all simplified by using good bus bars. For example, the ones that we chose from Victron, I think, help a lot. To simplify this quite a bit, a bus bar is nothing else but a copper plate. It has threaded holes so that you can put different cables. So for one, the battery is connected to that bus bar, and then also all the loads branch out from there, or the charging coming in goes into that same bus bar as well. It's just a common point, it's a gathering place. Next chapter is AC. So for that, we have a Victron inverter charger. It's the Multiplus 12 3000 120. 12 for our voltage of 12 volts, and then 3000 are the volt amps, similar to watts, that it can produce, and 120 are the amps that the charger can put out. Along with that, we are also installing an isolation transformer, but we haven't gotten to it yet because it hasn't arrived. An isolation transformer is used to transfer AC power from the source to the loads without an actual mechanical connection. So the loads are transferred magnetically. They have 2 coils. Basically, just picture one coil is energized and then magnetically it is transferred to the other coil. So there's no physical connection, which gives you isolation. Isolation on a boat is good for many reasons. And one of the one that probably most have heard about is for galvanic isolation. For example, you protect your zincs. They are a necessity. If you're on a metal hull boat, then you definitely should have an isolation transformer. They also prevent electric shock drowning, which is something that not many know about, but it's a pretty good safety feature, not to drown people swimming near your boat. Many of you probably have heard of a galvanic isolator. This is just an improved, better, much beefier version of that. Next chapter is monitoring. For one, like I said, these batteries can be tapped into via the app that I now have on my phone. I can look up what state they're in, how much is drawn out, what the percentage of the battery is, if there are any alerts. But we also chose to go with some Victron components where we can tap on the display and see what's going on as well. The battery monitor that we've chosen is a Victron Serbo GX. That's the brain box, that's where all the wires gather, and that sends the information to the GX touch display. This is a really handy device because the Battleborn app can tell me about the batteries. But since we have so many more Victron components in the system, having the Serbo GX, we can also know What is the solar panel doing? We could know how much AC is going out, how much charge is coming in. And the Serbo GX has many more features. So another one that I really enjoy and that we've already tapped into as well are monitoring tank levels. So we know now how much water we have and how much diesel we have. The last chapter is safety. Now, in many ways, maybe this should have been the first chapter, but no, they're not in right order of priority. So for one, what is really nice about this system is that it enables communication. Like we said, the hub tells you about the state of the batteries and it can send out alerts. To me, one of the biggest safety aspects is knowing your system. All components being able to be configured to charge lithium, to set the parameters. That to me is a very important part of it. One big concern regarding lithium is load dumps. I'm sure you've heard the term. Let me try to explain it simply. So since these batteries have an internal BMS, which basically is a switch that can cut the battery off from anything else if it sees something that it doesn't like. And so now we have the scenario of an alternator which is charging the battery at a pretty high rate. Let's say it's putting in 100 amps. And now all of a sudden the BMS senses that the batteries are full, they would not like to be charged anymore. It closes the switch. The alternator is still producing those 100 amps though because it wasn't notified, it wasn't told to do anything different. Those 100 amps don't have anywhere to go. They hit a wall. They bounce back. The alternator has to absorb them, which many don't. They go up in smoke. That to me is how I understand load dump in simple words. Now there is a couple of ways to mitigate that though, and one that I'm very excited about ties into our charging side, which is having an external regulator, which is the Wakespeed 500 Pro. The Wakespeed company has merged with Dragonfly Energy and now they work together. So there is really exciting features also still coming up. One of them is that the regulator can communicate through the Battleborn hub to the batteries. So now in the future, the batteries will be able to tell the regulator, we are charged, we're going to close down the house here, we're going to turn off the switch. The regulator notifies the alternator, you don't need to charge anymore. So then you prevent such a load dump. There is other ways to mitigate the results of a load dump. One of them is to use a high output alternator which was built better. Balmar alternators, they use avalanche diodes, and those are already much better in absorbing such high voltage spikes. And then there is also alternator protection devices, which basically also just is an avalanche diode. So we have both those additional things in place as well. We have the Balmar alternator made with avalanche diodes, and we have an alternator protection device in place as well. But I am very excited for when there is the additional communication. Dragonfly is projecting mid-June for these updates, so that's actually pretty soon. And maybe I should even look back a little bit. The biggest way of how people have avoided load dumps at the moment was to keep an AGM battery tied into the system. So basically you charge the lead acid battery and then you charge the lithium from that lead acid battery using a DC to DC charger. The one downside of that is that DC to DC chargers are usually smaller in size, so either you would have to put in many in parallel to get an adequate charge, because one of the biggest benefits of lithium is the amount of charge that it can take. So I didn't want to hamper that benefit by charging it slowly. Whenever the engine is running, I would like to charge with those 170 amps that our alternator can deliver, but it has to happen safely. To me, I also see a little bit of redundancy by having separated the house circuits and the start circuit. By keeping the start battery separate, I see it as always being able to start the engine, even if the BMS has shut down the lithium house bank for whatever reason. That's just an extra step of redundancy. So that pretty much completes our electrical diagram. Things that are on the electrical diagram that I haven't mentioned are, for example, the windlass, which is a pretty big load. And we also have all of our switches and fuses and circuit breakers sized according to our system. And not all fuses are shown on this diagram. You can, for example, see that I haven't put in every single load and switch on the DC panel either. This is a broad overview. Now it's time for the actual install. In with the new, out with the old. Will they be this way one day? This took me a couple of weeks, and I won't get into every single wire. It's more about the broad ideas behind it, the schematic, like I said. I didn't film every single wire and screw and fuse that I put in place, because it would be a pretty tedious video if I did. But I did make sure that every circuit that I put in place, that it is sized accordingly using the correct cable. I use tinned wire throughout the boat. Mostly I use Ancor wire with a 105-degree temperature rating on it. And I use the Blue Sea Circuit Wizard app to determine cable size for the length and for the load, and I also select the fuses using that app. So when I open it, the first thing that you have to put in is voltage, then what is the load that you're planning to power, so then you put in how many amps that would draw, the length of the conductor, and then the allowed voltage drop, anywhere from 3 to 5% I would say on a boat. And then the insulation temperature rating, which for, like I said, all the cables that I bought is 105 degrees. Then if it is installed in an engine room or not, you have to click yes or no, because higher temperature affects that. And then also how many wires are in that bundle. It is a little bit of a difference if it's only one cable going somewhere, or if it's in a conduit where you have 20 others that also accumulate heat. And then what's the duration of how long that appliance is run, and if it's terminated on a fuse. You put all those things in and it spits out the wire gauge that is required for that circuit. Of course, you could also do this calculation by opening Nigel Calder's book, not using the app. That's probably how Brian would do it. Almost done on the inverter. Details are missing. I'm starting with the big bullet points, which is positive and negative. Of course, then there is the ground, and also grounding it to our main grounding bus here that is on the outside. Yeah, so I am actually though focusing on the links bus bars, all the connections that go there. So next I may look into drilling a passage to get to the DC panel to feed the loads, and then also measure a wire run to see how long the cable has to be that goes to the alternator. A little disassembly on this side now, figure all of that out, and make those last few connections. Moving on to one of the most exciting components in the entire system. Inverter chargers here, batteries are in here, bus bars, shunt, a regulator. Little box, beefy plug here, and then this is where the hub goes. That's the harness. It's just really beautifully done. So what do we have here? So it's 3 legs. One leg requires going to the panel. One leg goes to the alternator and one leg goes to the batteries. All of these little cables, they communicate something, and the wake speed regulator is smart because it has all of these tentacles that go somewhere and relay information. And indeed, finally, smart squid, electrical squid. There it is, and now I actually want to screw it in place.
I just brought an afternoon snack for Aladino, and I brought him some mango. I thought that we had forks on board. Apparently, we don't.
And all. So I think now that
Good for all purposes.
For all purposes.
Can you do a brief overview of where you're at in the process and what's next?
Details, requirements. In the negative circuit goes through a shunt, and the shunt is basically a current measuring device. So the shunt gets connected to a little screen, and then we can watch everything on the screen. Sorry Maya, last clip. I meant to do a time lapse, but nothing too crazy happening anyway. I'm just illustrating a little bit of wiring in here. And now back to the video. Very exciting moment. Well, display is in. I am really curious now to see if the batteries are alive. And I could do it old school with a multimeter, or I could go into the app, say hello, because you have to configure your bank. I would like to place them in my app, how they are on here. So you go to the Battleborn app. I think it will show up in my systems once it's done, but for now I'll have to set it up. Oh, it already detects the hub. So now it's connecting, desired system voltage. Our system will be 12 volts. We have the 100 amp hour number of batteries. So now I have to select here. We put it on 4. And now it knows a 12 volt system, 400 amp hours, and the batteries are in parallel. So let's hit continue. I'm happy with that. Oh, it already detected the batteries too. This is gonna take me just a little longer, so maybe Maya wants to edit it here. Before I put the batteries in there, I took a photo of their QR codes just to know which one I put where. I want to know specifically which battery is where, so I'll have to go through my notes just to find out real quick. Left number 3. Okay. Now I go back into my photos. The one getting closer towards us ends in 175. Let's see. Number 4 goes over here. Complete system setup. Oh man, let's give this a minute. But I'm so excited. It's firing up. It's communicating. It's showing up. Oh, this is so amazing. Ah, what a relief. What a relief. We only have 3 weeks to go until we splash. Last step, setting, finishing, loading system data. All right, look at that. Oh, are my batteries empty? Voltage 13. Oh no, there you go. It took a minute. State of charge remaining. Oh, so 276 amp hours. And yeah, as we give it charge, they will all balance out. That's another really neat thing about this individual control over batteries, is that when they charge, one battery can step out and say, I am charged, but it doesn't mean that the other batteries don't need charge still. Everything is working as it should.
So I thought the best thing to do at this point will be just to get Aladino to give you guys a little bit of a tour of what we have now, start to finish, because not every little detail has been filmed along the way. There's been a lot of 1 a.m. missions. All right, Aladino, I'll turn it over to you.
Yeah, different to last season, we have an incredible electrical system now, I might say. So, batteries, they go to the bus bars. They are fed on the sides, so you can see here is the input from the batteries, a switch. Back there, actually, that's a T-class 400 amp fuse, as close to the terminal as possible, but then we wanted to feed, well, positive goes this way, negative goes the opposite way. That's just a proper way of doing it, I heard. And then all the loads go to all the places. I even managed to put in a little bit of labeling, as you can see, so I know that one there is feeding the load panel, the DC panel. Well, starting with the very first connection, those tiny wires, 10 gauge, that's solar that is coming in already. Then we got the DC panel loads. Then we have one crossover to mix in the AGM start battery, but that shall never be used. That's just emergency. Wind, that's the windlass, and then we got two big 1/0 cables feeding our inverter. At the back, those are very beefy MPPT controllers. I can very much see adding more solar. Also, if we start including the 200 watt panels from Bluetti that we still have, then it starts adding up. These have built-in Bluetooth. They can be wired into the GX, into the servo panel via a V direct cable or RJ45. So that is done now with only one, because we have two 100 watt panels at the moment, and one of those MPPT controllers is totally fine for that. And you can also see our shore power is up high in the cockpit, so it comes in there, that little orange square thing. That's our shore power plug, which I wired in. It comes down to the quarter berth, and that one flat triplex wire, that's our AC. AC comes in and it goes under the chart table. So shall we continue there?
Sure.
I made this little channel for all the wires to go through. It will still get a lid. And over here we have the inverter charger. It's a Victron Multiplus 12-3000. And I've wired in, for now, I wired the AC to feed the inverter charger. We are still waiting on an isolation transformer. There is the perfect spot for it right there. Mm-hmm. So installation is just waiting to happen. Everything is ready. So later we will feed the isolation transformer directly, and from the isolation transformer output, that will feed the inverter charger. So I will just have to swap one connection, famous last words. Now moving on to the rest of the systems in here. This is our start battery, Lifeline AGM battery, and I've added a fuse, as you can see. This is a 300 amp mega fuse, so the idea is that it's a slow blow fuse. It's oversized, it shall not get triggered. But in those rare situations that something doesn't go well, then there is a fuse. But we don't want it to nuisance blow just by, for example, cranking the engine a little much on a cold day. Then you don't want it to trip the fuse. And the controls of start battery. This is the start battery switch, so you can see it's on now because I was doing some tests, but off it is now. And this switch here, you can disregard. It's only there for emergency. As my quick label says, never turn this one on if this one is still on, because this is the crossover switch that connects either this battery to the rest of the boat or the battle-borne batteries to the engine, but you shall never mix different chemistries. So we always have to make sure to take this one offline. And now if I was to cross over, then we could emergency start the engine with our
You should
bank.
almost put some tape on the switch itself.
Yeah, I can do that.
Yeah.
I don't see needing it, but it's there. So that's that side of things. Coming back here, you can see the bus bar, and I have grounded the case of the inverter to it. This one is for the isolation transformer once we get it to also ground the casing. So that summarizes that part. One of those cables from the bus bars feeds the alternator, or the alternator feeds the bus bars is a better way of putting it. So that soon we can get a lot of amps from that Balmar XT170 alternator. It can handle charging lithium batteries at continuous output, which is what lithium can take. It's still a good practice to derate the alternator a little bit because they tend to get hot. So I will do all that, and that is actually easily done via the alternator regulator that we have, amongst other things that it does. So this one here, back here we got the brains of all of this, and so the big brain related to the alternator is the wake speed, and then over here that's the hub. That's what allows everything to communicate with the batteries, and that's also what sends out the Bluetooth communication to the app. And as you can see, one thing that I didn't manage to get around quite yet is to do this neatly. I'll have to go around and put in some zip ties. In the future I could see maybe upgrading some sides of the panel a bit. Obviously we'll put on labels, but same thing. Before I really know what we need and where we want to put it, and how much power it requires, because every circuit breaker is different. We can swap them, of course, but until all of that is more or less dialed in, I'm not putting in the new labels. And that brings us to this one here. That is such a cool battery monitor.
Now here we have straight from the 80s, and here we have straight from the future.
Yep. Well, I mean, this I already modernized by putting in a Victron 712.
Yeah.
But this one is offline right now. This one is in case everything fails. We still have one since we already had one bought it.
So this is really fancy and lovely.
Yeah, so I still need to do some configuration. Still have work to do in the settings.
Why does it say that the solar panels are taking in 0%?
That's what I'm saying, because I disconnected the panels.
Oh.
You can see shore power, AC loads that now we do have, and that's the battery bank. Right now 9 watts are being drawn from it. It's at 93%. And DC, that's our load panel. Right now it's using 9 watts. It's just because some things are on standby. Well, this is the brains of the battery monitor, the Serbo GX, and all the wires lead to it. There's a lot of things housed in this seemingly small and simple boat.
But we still don't have lights.
But we still don't have lights, that's right. That's the most complicated thing of it all. Yeah. What do you mean?
Okay.
Yeah, we have some lights. So, the AC. Now I wired up AC as well. So the panel on the inverter isn't on, but this one is a switch. So if I flick it, that turns it on. That is on right now. Green light, that means inverter is on and working. So we're not connected to shore power right now, so that means it is converting DC power into AC power. That's what an inverter does. And here is our beautiful AC panel, which has been relocated. You saw the big hole in the electrical panel. That's because that's where it used to be, but I just prefer keeping wire runs short, not bringing AC all over the place. So I really like the solution. We don't use AC too often, so it's hidden away regardless. I have wired in 2 circuits. One is a GFCI outlet that is right here under the chart table. Check it out.
Yeah.
And it's accessible for chart table work or galley work.
Yeah.
The other connection is the hot water tank. Now, right now, we can still plug the hot water tank into this, into shore power, so to speak, while we're here. But once we're off, then I can hardwire it in to that switch so that we could run everything off of the boat. Let me test it again.
Amore, this is all incredible. I'm so deeply impressed with what you've done here.
Me too. It still will be some nights over the literature, but overall things are becoming so user-friendly, and yeah, with a little bit of common sense, yeah, it was nice to put this all together. And now it's just about the details of a little bit of wake speed settings, a little bit of servo panel settings, and then I might have to log into the inverter charger too, because yeah, as the devices get smarter, you also have to tell it what you want, because they can do many things, but not if they don't know what you want. So I have to tell them those things. But I figured that is less of a destructive phase thing where I need tools and I need to move a bunch of things. It's literally either going onto my phone, connecting to it. I leave those for last minute. Yeah.
Well, amazing work, Aladino. This has been a huge project, and
yeah, and an exciting one. And
yeah.
I'm very glad that I had the opportunity to put it together.
Yeah.
Yeah, I always like knowing things, knowing the bottom of things, so troubleshooting becomes easier. I know what is in place, I can fix it. Well, I put it together, so yeah, hopefully I know what is where, and if things go sideways, what the cost could be. Hello, baby bunny boo, editing bunny of the future. Let me zoom out here. What is this shenanigans? And maybe I have learned that I leave you little messages before I take a 45-minute clip and not afterwards, because then you have watched it and you go, what the fuck should I do with that? And then I explain. Anyway, little explanation of the clip that I just took.